So there's a category of math problem that involves counting path, either on the checkerboard or on some sort of grid. The key to solving those kind of problems is to make sure you don't miss any of the path or you don't double count any of the path. So the key to solving that problem, of course, is to be organized, as we mentioned before, to be more organized. And by being organized, it depends on what kind of problem, which specific problem you're trying to solve. For example, right, in this problem over here, this is one of the Beast Academy problems. This problem says, how many different checkerboard paths can be drawn on the grid below? There may be less than 8, of course, okay? Well, to solve this problem, we want to be organized. How do we want to be organized? Well, on every position we can be, we can either turn left down, right? Left down, or right or up. So what we do is, for this kind of problem, we will try to go left, and second, down. If not, third, right, and then the fourth step, go up. Right? And then, every time when we go to another loop, another iteration, we'll put some note in there indicating, oh, we haven't explored that direction yet, and we'll come back to it and try to explore that direction. You can come up with your own notation. I like to put a question mark or a circle at a point where I have yet to explore. For example, right, let's go through this problem together and see how we can be organized and get the result. So the start position's over here, right? And we want to explore, right? We want to explore the grid, okay? Well, let's see how many paths we can get. Right? All right. So let's first go left, right? So we go here. Once we go here, the only way is down, right? So no left, no up. Only way is to come down. But here we have a choice, right? We can go down, we can go right. Based on our rule over here, we'll first go down. But we need to put something over here and make sure we come back and explore this path so we don't forget it, okay? And the next one, the only path is go right. But now we have a choice, right? We can go up or go right. Based on our rule, we go right first. But we put a circle over here, make sure we come back and explore this branch. Now, once we're here, still, we could go up and we could go right. Well, up, we'll put another circle over here and make sure we come back here and explore this branch. Now, over here, we can only go up, but once we're here, we have two options. We can go left, or we could go up. Based on the rules we have, we go left first, but we'll put a circle over here, make sure we come back and explore that branch. So once we're here, we have another two options, right? Go left or up, right? We cannot go down because that square is already visited. But if we go left, what happens is we cannot go anywhere and we're left with these two not explored. So we cannot go left either. So the only way is to go up, right? Okay, so once we go up, and then we can go right. But even if we go up, we cannot come back here. So this node will never be explored. So that means this path doesn't work. So we need to trace back. So we'll trace back to the first branch over here we have yet to explore, right? So this is the one we need to explore. So we'll go up over here, and the only way is go left, right? And start this box, this square is explored, so we'll have to go down and come back here. All right, so this is the end. All right, so this is the first path. Okay, now let's come back and explore another branch that we have yet to explore, which is this guy. Okay, now, so we'll go trace all the way here, right? And we'll go up here. But once we go up here, we notice that if we turn left, there's no way to visit these guys. If we turn up then or right, this guy is left alone and it will never be visited. So what do we do? So this is not a valid branch either. So this guy is not valid. Okay, what is the previous one? The next one that's not explored is to go up over here. Okay, so this is something new, right? So now once we go up here, we finished exploring this guy now. Okay, now we need to, the only way is to turn right. Once we turn right, then we have three options, right? We could go down, cannot go left, we can go down, right, or up, right? We can go down, this is the one we are going to explore first, based on the rules. And we can go right, but once we go right, we'll notice that either this one or this one will never be explored, so we cannot go right. So this is not a valid direction. So we can go either down or up. So let's go down first, but up, we'll put a circle over here. Make sure we come back and explore it. So we go down, and then we have to go right, have to go up, and have to go left. This is where we end. This is the second valid path. Okay, and then this is where we have yet to explore. Okay, now this is the second one. Okay, now let's explore the other options. So we go here, right? Here. This is the one we need to explore. So we go up first, and then the only options are these guys. So this ends over here, right? So now that's the third route path that we have. Okay, and this one is actually explored. Now we need to trace all the way back to this guy. Okay, so this is the one that we have not explored for turning left from the start position, right? And of course we can turn down, there's another one, and turn right, there's another one. We have to come back to explore that one. Okay, so now we go here, so we are going to explore this one. Remember, the downward path is already fully explored. Okay, now we go here. Once we go here, we cannot go left, we could go down, and we could go right, right? Based on the rules, we explore the downward path first, but we notice that once we go down here, we have either this guy or this guy. Either one, wherever we go, the other one cannot be explored anymore. It was separated into a lonely island. So what happens? So that means this doesn't work. So the only path is to turn right. Okay? Okay, so the only path is to turn right over here. Right? Okay, so turn right. Once we turn right, we have three options, right? We can go down, go right, or go up. But similarly, if we go down, this separates these two guys and these guys. And either one of them, maybe either direction you turn after this step, you will not be able to explore the other subset of squares. So what this means is that coming down is not a valid is not a valid path. Similarly, turning right is not valid either. And then we have to go up and then go this direction. That's the fourth path. Okay, now we have explored everything when we turn right over here. Okay, so this is everything. And now we have explored everything where we turn left at the start position. Okay, now the next one we explore is turn down. Okay, once we turn down, we go over here, right? Now, even if we want to turn left over here, down over here, or right over here, 3 different options, right? Okay, so turn left, similar analysis as we had before. Either this one will not be visited or these guys will not be visited, right? So left is not a valid direction. So left, not valid. Similarly, come down here, similar problem, not valid. And we have to go right. Once we go right over here, and we have 3 options. We can go up, we can go down, right, or up. Go down, come down, go right, we are faced with the same problem. There's a subset of squares we cannot visit. So we have to go up. So we go up over here, and the only options are these guys. Okay, so this is the next path. And by doing that, we have explored every path possible from start position going downward. Now, the one that's left is to go, only one that's left, right? This is explored, is to go right. So once we go right, we're faced with 2 different options, right? Both of them seems to be valid for now, okay? So let's, as we did before, let's put a mark on the path that goes to the right and then go try the path that comes down. All right, so now we can go 3 different directions: left, down, or right. Similar analysis, down is not a valid option, and right is not a valid option either. Right? Why not? Because if you go here, then this guy or this guy cannot be visited. Right? All right. So turning left. Let's turn left and see what happens. Right? Turn left over here. So we turn left. Then we're faced with 2 options. Right? You cannot go up. Start has already been visited. So we can go left or down. Right? Either way, it's a dead end, because if you go left, this one or this one cannot be visited. If you go down, this one or this one cannot be visited. So coming down over here, this means coming down over here. This is not a valid path. There's no valid path. So what we do is, so we can only go right. So once we go right, we're here. There's only 1 option to go down. Once we go down, come down, we're faced with 2 different paths. We could go left or we could go down. So let's explore the left side first and put a mark over here to make sure we remember to come back here and explore the other branch. So we go left, then we're faced with 2 options. We can go left or we can go down. When we come down, this path is not valid, because if you come down, either this one or this one cannot be visited. So that means we cannot come down. So this is not a valid option. And then we have to come left. Same thing. When we're here, we can go left or we can go down, but either way, we will have a square that cannot be visited. So this is not an option. What does this mean? This means turning left over here is not a valid option. You have to come down. Once you come down, the only option is to come left, right? Once we come left, what can we do? Once we come left, there are two options. We can go left or come up, go up. Go left or up, right? Let's go left first. Let's go left first, and then put a circle over here to indicate that we need to come back and revisit that branch. Okay, once we go left, then we are faced with another two options, right? We can go left or we could go up. Well, let's put a circle over here to make sure we come back. Once we go left, we can go up only. Now we're over here. We're faced with a problem where if you go here, it's a dead end, right? You cannot go anywhere. And there are still some squares not visited, so this is not valid. If you go right, then this guy is an island that cannot never be visited. What does that mean? So that means turning left, the last branch that we made was not valid. Okay, so now let's see if we can go up. Once we go up, no, either this part or this part cannot be visited. So this means going up over here is not a valid step either, right? So we're only left with going up over here. Once we go up, the only way is to turn left, right? Turn left, then we are faced with two options, either left or down. If we go left, not valid, because either this one or these two will be isolated. Right? So this is not valid. So the only path we can go, so left is not valid. Only path we can go is down and then go up. Right? So by doing that, we have explored all three different directions we can go at the start position, and these are all the possible paths. Okay? So by doing this, you are sure that you are not missing any, or you are not double counting any of the path. And there are also some other problems that this is one of the previous AMC 8 problems where there's a checkerboard and is asking us to count the possible path from P to Q. The problem says a game board consists of 8 by 8, 6 foursquares that alternate in color between black and white. The figure below shows square P in the bottom below, right, in the bottom row, and square Q on the top row. A marker is placed at P and Q. A step consists of moving the marker onto one of the adjoining white spaces in the row above. Okay, only goes to the white space. How many 7-step path are there from P to Q? Right? So to solve this problem, we need to again be organized and see what we can do. This problem is a little harder. It's a different problem. It's a little harder. Well, let's see, right? So one thing we can observe is from P, you can go, the furthest you can go is this line, right? You can never touch here. Once you're here, then there's really no route to Q, right? Because P doesn't come here, okay? And then on this side, you can go this direction, but cannot come this side to this side. But if you're here, you can never reach Q because the rightmost you can go is here. Similarly over here. So that means if you keep going left from P, the leftmost you can go is here. Okay? So now this problem becomes a little easier, right? So we're dealing with these white spots, right? P has to move within this area. All right? So now, forget about Q for now, right? If we want to go from P to this white box, how many paths do we have? We have one path, right? Only one way to come here. Similarly, only one way to come here, right? And similarly, only one way to come here. But when we come here, we have options. We can go from P to here, or P to this box to here. So we have two options. So what does that mean? So that means the number of paths over here is nothing but the sum of the two underneath it, right? All right, that's good to know. And similarly over here, it also follows the same rule. So this is 1, right? And this one is 1 also, right? And this white box over here, we would have 3 paths, right? By using this method, we're not double counting and we're not missing any of them. And similarly over here, we have 3 over here, right? And similarly here, we have 3, here we have 6, here we have 4, here we have 10, here we have 9, right? Now here we have 19, and here we have 9. So therefore we would have 28 paths over here. So looking at these two different problems, right? So we got one problem over here and one problem over here. We have different ways to organize the path we need to count, but the methodology is the same. You need to be organized, and you organize the different paths into different groups, and the goal is to make sure you don't miss anything and you don't double count any of the paths. This is the key to solving this kind of problems.